Hello everyone, I am Abhijit Lal, Assistant Professor, Department of EEE, Bhilai Institute of Technology, Durg. Today we are going to study about the clipper circuit. As we have discussed in the applications of Zener diode, that Zener diode gets its application for the clipping circuits. So, clipper circuit is a very important device used in various electronic circuits, where it is used to clip some parts of the sinusoidal wave. So, the contents for the clipper circuit will be the introduction part, then we will see the types of clipper circuit, then series clipper, shunt clipper and dual or combination clipper. So, what is clipper? The clipper circuits are the electronic circuits that clip off or remove a portion of an AC signal without causing any distortion to the remaining part of the waveform. So, these are also known as clippers or clipping circuits or limiters or slicers, etc. So, the below figure shows a simple clipper circuit which is having a diode, a resistance and input and output. So, we can see the output here is that the half wave rectifier. If we take an example of a half wave rectifier, it is a best example for a clipper circuit. Here what it is seen is that the input wave is having both the positive half and negative half, but the diode is working in the forward bias region and it acts as a open circuit in the reverse bias region. So, in this way it is giving the output in only positive half and it is not giving any output in the negative half. So, in this way we can see that this circuit is clipping off the negative half part of the source voltage. So, we are getting the value from 0 to pi, and from pi to 2 pi we are not getting any output. That means we can say that it is clipped or removed, and again for the positive half the output is obtained. Now, what is the need of clipper circuit? Why it is used? So, in electronics there are different sensitive components or circuits whose operation depends on the waveform of the input signal. So, if the voltage rises above a limit, it may affect its operation and causes a problem in the circuit. Most electronic circuits operate on a sinusoidal waveform. So, in order to avoid the voltage rising above or below a certain limit, the remaining portion of the waveform is clipped. So, the clipper circuit uses such a method to prevent the voltage from rising above a certain limit. So, this is the need of clipper circuit. Now, let us see the types of clipper circuits. The diode based clipper circuit can be classified in the following types. The clippers are very different types for different applications. So, if we say in a broad way, it is classified as series diode clippers, shunt diode clippers and third is dual or combination clippers. But between that we have the classification as in series diode clippers, the series positive clipper is present and second one is series negative clipper. Similarly, for the shunt diode clippers we have shunt positive clippers and shunt negative clippers, and after that they are again classified according to the biasing, that is the series positive clipper with positive bias and series positive clipper with negative bias. Similarly, series negative clipper with positive bias, series positive clipper with negative bias. Similarly, the biasing is done for the shunt clipper also. So, for shunt positive clipper there are two types of biasing: shunt positive clipper with positive bias and shunt positive clipper with negative bias. And lastly, the shunt negative clipper with the two biasings, that is positive and negative biasing. So, in this way we have a wide variety of clipper circuits which is required according to the applications required. And third one is the dual or the combination clippers, in which clippers are used in the combination. So, the following picture shows the classification of clipper. So, what we have discussed here is it is showing in this picture the different types of classifications for the clippers. So, let us study one by one all the different types of clippers. So, first start with the series clippers. Why it is called as series clipper? In series clipper circuits, the diode is connected in series with the output. That is why it is called as series clipper. In such clippers, the input signal appears at the output when the diode is forward biased and conducting. On the contrary, the shunt clippers passes the input signal when the diode is reverse bias or blocking. So, it is divided into positive and negative clippers. So, first one is the first classification in series clipper is series positive clipper. So, series positive clippers removes or clips the positive half of the waveform. In a series positive clipper, the diode is in reverse bias and in series with the output as shown in the figure below. So, here two word is coming, first is series and second is the positive. So, series means the diode is in series with the load, and second positive means positive word is showing that this clipper is clipping the positive half of the waveform. So, the below figure shows the working of the series positive clipper. In this, the diode is connected in the reverse bias condition, and when the positive half of the input comes, it clips the positive half of the input, and it only allows the current to flow, the waveform to flow to the output is of the reverse bias condition or the negative side. So, the negative half is shown in the output and the positive half gets clipped off. So, in this way the series positive clipper works. The input signal Vi is applied at the input side while the output is taken at the load resistor. During the positive half cycle of the input, the voltage at point A is positive than point B. So, the diode is in reverse bias condition and there is no current conduction. The input signal cannot pass, thus there is no voltage drop at the load R. Therefore, the positive half cycle does not appear at the output as shown in the figure. During the negative half cycle, the voltage at point A is negative than at point B. So, the diode becomes forward bias and the signal passes through it. So, the signal appears across the load R. Therefore, the negative half cycle passes through the circuit and appears at the output. Therefore, the series positive clipper clips the positive half and allows the negative half of the input waveform. Series positive clippers with biasing. The biasing in the clipper circuit is used to clip a portion of the half cycle and not the whole half. Therefore, a series positive clipper with biasing, which can be positive or negative, is used for producing the desired waveforms. Now, what the main purpose of biasing is to clip the portion of the half, as we have seen here in the positive series clipper that the whole positive half is clipped from the output. But suppose if we want to clip only some part of the positive half, or we have to add some part in the positive half, the biasing is done. So, here there are two types of biasing. First is positive biasing and second is negative biasing. So, let us see the series positive clipper with positive biasing. In a positive clipper circuit, the positive of the battery is connected to the P side of the diode as shown in the figure. So, with the load side, or we can say that a battery, the direction is of the voltage is kept such that it works as a positive biasing. So, the positive of the battery is connected to the P side of the diode. So, this forms the positive series clipper with positive voltage. During the positive half cycle, the voltage at point A is greater than point B, due to which the diode is in reverse bias and switched off. But there is another voltage source whose positive is connected to the P side of the diode. This voltage source or battery puts the diode in forward bias. If the input voltage is less than the battery voltage, the diode remains in forward bias and it conducts. Therefore, the signal appears at the output. When the input voltage increases above the battery voltage, the diode becomes reverse bias and does not conduct the input signal. Therefore, the battery voltage VR appears at the output. During the negative half cycle, the diode is forward biased due to the input voltage as well as the battery voltage. Therefore, the input signal passes through the diode and it appears at the output. Now, let us see the series positive clipper with negative bias. So, the battery in the negative bias series positive clipper is connected in reverse with the diode as shown in the figure below. That means, the negative side of the battery is connected to the P side of the diode, which forms the negative biasing for the series positive clipper. So, in this way voltage obtained is reduced for the negative half. Without biasing we are getting the whole negative half at the output, but using this negative voltage or negative biasing, some part of the negative half of the waveform is also clipped. During the positive half cycle, the diode is reverse biased due to the input voltage and the negative battery as well. Therefore, in the positive half cycle, the diode does not conduct and only the negative battery voltage appears at the output. During the negative half cycle, the input voltage polarity reverses and the diode becomes forward biased. However, the diode is reverse biased due to the negative battery. Therefore, the diode only becomes forward biased if the input voltage increases above the battery voltage and the input signal appear at the output. Otherwise, the negative battery voltage appears at the output. Now, let us study about the series negative clippers. So, what is series negative clipper? The series negative clipper circuit clips the negative half of the input cycle. Its circuit diagram is shown in the figure. Again, the two words are coming, series and negative. So, series means the diode is connected in series with the load, and negative means this clipper circuit clips the negative half of the waveform. So, that is why it is called as series negative clipper. So, the working of series negative clipper can be explained as during positive half cycle, the diode is forward biased due to the input voltage. Therefore, the input signal passes through the diode and appears at the output. But during negative half cycle, the diode becomes reverse biased and it does not conduct. Therefore, there is no voltage at the output and the negative half cycle is clipped from the input waveform. Now, the biasing in series negative clippers. The series negative clipper is biased with either positive or negative voltage battery to modify the waveform instead of clipping the whole negative half. So, again there will be two types of biasing, that is positive biasing and negative biasing. So, let us see first the series negative clipper with positive biasing. During the positive half cycle, the diode is forward biased due to input signal voltage, and the below figure shows the series negative clipper with positive bias. Positive bias means the positive part of the voltage is connected with the diode in the terminal N part. So, this forms the negative clipper with positive biasing. The N terminal of the diode is connected with the positive terminal of the voltage. So, the waveform is showing the output, that means a normal negative clipper is giving the whole positive half with the output, but by positive biasing we can clip some part from the positive half also. So, the explanation for this working can be seen in detail like this. While it is reverse bias due to the battery voltage, the state of the diode depends on both the voltage sources. Therefore, the diode will be forward biased and conduct only if the input voltage is greater than the battery voltage. At first, the input voltage is lower than battery voltage, therefore, the diode is reverse biased and does not conduct. So, the battery voltage appears at the output. The input signal appears at the output for the portion when it becomes greater than the battery voltage as shown in the figure. During the negative half of the cycle, the diode is reverse biased due to both the input voltage as well as the battery voltage. Therefore, only battery voltage appears at the output for the whole negative half cycle. Now, let us see the working for series negative clipper with negative biasing. During the positive half cycle, the diode is forward biased due to both the input signal and the battery voltage. This is shown in the figure here. Therefore, the diode conducts the signal for the whole positive half cycle and it appears at the output as it is in the input. So, in negative clipper with negative biasing, the connection is such that the N side of the diode is connected with the negative part of the battery. So, this forms the series negative clipper with negative bias. During the negative half cycle, the input voltage forces the diode in reverse bias, but the battery voltage still forward biases the diode. During this whole cycle, the diode only conducts when the battery voltage exceeds the input voltage. At first, the input voltage is less than the battery voltage, thus the diode conducts and the signal appears at the output. But when it exceeds the battery voltage, the diode blocks the input signal and the battery voltage starts to appear at the output as shown in the figure. So, this was all about the series clippers, in which we have seen the series clippers and it is having the they are having the two types, that is series positive clipper and series negative clipper, and with their biasing circuits, that is positive biasing and negative biasing. Now, let us study about the shunt clippers. In shunt clippers, the diode is connected in parallel with the output, and from this, then for the shunt clippers, the input signal appears the output when the diode is blocking, as opposed to the series clippers. The shunt clippers can be divided into positive and negative clippers. So, again we are having two types of clippers for shunt clippers, that is shunt positive clippers and shunt negative clippers. Now, let us see shunt positive clippers. The shunt positive clipper clips the positive half cycle of the input waveform. The circuit diagram of the shunt positive clipper is given below, in which we can see the diode is connected in parallel with the load, and that is why it is called as shunt clipper. During the positive half cycle, the diode is forward biased as the voltage at point A is greater than point B. So, the diode conducts the input signal and there is no voltage difference at the output. During the negative half cycle, the voltage polarity of the input signal at points A and B reverses and the diode becomes reverse bias. Therefore, the diode blocks the input signal and the signal voltage appears across the diode, that is taken as the output of the clipper. In such a way, the shunt positive clippers clips or remove the positive half of the input cycle and allow the negative half cycle. Shunt positive clippers with biasing. So, the biasing is done by which another fixed voltage source, such as a battery inside the circuit, to modify the waveform furthermore. So, a battery is used to modify the waveform more different ways. So, that is called as the biasing. So, the voltage source can be connected in either positive or negative biasing. Therefore, there are two types of biasing: shunt positive clipper with positive biasing and shunt positive clipper with negative biasing. So, let us see first the working of shunt positive clipper with positive biasing. During the positive half cycle, the diode is forward biased due to the input voltage, but it is reverse biased due to the battery voltage, and this is shown in the figure. Here a biasing is applied, positive biasing, in such a way that the positive of the battery is connected to the N terminal of the diode. So, this forms the shunt positive clipper with positive biasing. So, the sum of both voltages will decide the state of the diode. If the input voltage is greater than the battery voltage, the diode will be forward biased, otherwise it will remain in reverse bias. At first, the input signal is less than the battery voltage, so the diode is reverse biased and the signal appears at the output. But when it exceeds the battery voltage, the diode starts conducting the signal and only the battery voltage starts to appear at the output. During the negative half cycle, the diode is reverse biased due to both input voltage as well as battery voltage. Therefore, the input signal appears for the whole negative half cycle at the output. Now, next is shunt positive clipper with negative biasing. During the positive half cycle, the diode is forward biased for both input signal and battery voltage. Therefore, the diode conducts for the whole cycle and only the battery voltage appears at the output. This can be shown with this figure, in which the biasing is done such that the negative side of the battery is connected to the N terminal of the diode, due to which a negative biasing is obtained for the shunt positive clipper. During the negative half cycle, the diode is reverse bias for input signal and for forward biased for battery voltage. The combined effect of both voltage sources decides the state of the diode. The diode is forward biased when the input voltage is less than the battery voltage. At first, the input signal is less than the battery voltage, thus the diode is forward biased. Therefore, the battery voltage appears at the output. When the input voltage exceeds the battery voltage, the diode becomes reverse bias and the input signal starts to appear at the output as shown in the figure. Now, let us see the shunt negative clipper. The shunt negative clipper clips the negative half of the input waveform, the circuit diagram for which is shown in the figure. So, the purpose of negative clipper is to remove the negative half of the supply, and it is called shunt clipper because the diode is connected in parallel with the load. During the positive half cycle, the diode is reverse bias, thus it blocks the signal that appears across it. Therefore, the positive half also appears at the output. During the negative half cycle, the diode is forward biased and it conducts the signal. Therefore, there is no voltage at the output for the negative half cycle. Thus, the shunt negative clipper clips or removes the negative half of the input waveform. Shunt negative clippers with biasing. To further modify the waveform of the shunt negative clipper, positive or negative biasing is used with it by connecting a battery source in one of the two ways called positive biasing and negative biasing. The waveform can be modified by varying the voltage of the battery. Therefore, again there will be the two types of biasing, that is shunt negative clipper with positive biasing and shunt negative clipper with negative biasing. So, let us see first the shunt negative clipper with positive biasing. So, during the positive half cycle, the diode is reverse bias for input voltage, but forward bias for battery voltage. Shown here shows the shunt negative clipper with positive biasing. So, the connection is such that the positive of the voltage or voltage source or the battery is connected to the P side of the diode. So, the diode will be reverse bias only when the input voltage exceeds the battery voltage, and then the input signal will appear at the output. At first, the signal is less than the battery, so the diode is forward biased and it conducts the signal. Therefore, only the battery voltage appears at the output, but when the input signal exceeds the battery voltage, the diode becomes reverse biased and the signal appears at the output as shown in the figure. During the negative half cycle, the diode is forward biased for both input signal and the battery voltage. Therefore, the diode conducts and only the battery voltage appears at the output for the whole negative cycle. Next is the shunt negative clipper with negative biasing. So, how the negative biasing is obtained for shunt negative clipper? The negative side of voltage source or the battery is connected to the P side of the diode. So, by doing this we obtain a negative biasing for shunt negative clipper. So, during the positive half cycle, the diode is reverse bias for both input and battery voltage. Thus, the diode blocks the voltage and the signal appears at the output for the whole positive half cycle. During the negative half cycle, the diode conducts when the input voltage exceeds the battery voltage. Therefore, when the voltage is less than the battery voltage, the diode blocks and the signal appears at the output. When the input voltage exceeds, the diode starts conduction and only the battery voltage appears at the output. With this, we have covered both series clipper and shunt clipper, in which we have seen the positive series clipper and the negative series clipper. Along with that, we have seen the shunt clippers with the positive and negative direction. So, the words negative and positive here shows the clipping, the part of negative half and the positive half. Along with that, we have seen the importance of biasing, that means how the waveform is further improved by using the biasing circuits. So, by using the biasing circuits, again the two types of biasings we have studied, that is positive biasing and negative biasing. So, by applying the biasing, we can improve or we can modify the waveforms for the different clipper circuits. So, the last classification of the clipper is dual or combination clipper. So, dual clipper or combination clipper can clip a portion of from both positive and negative half cycle of the waveform. So, the picture shows the circuit for the dual or combination clipper. In this, we can see the two diodes are used and they are connected in parallel with the load, but in opposite direction. So, this is how the dual or combination clipper works. So, the purpose of dual clipper is to clip or remove the waveform from both the halves. So, if we are using the combination clippers without biasing, then we will not get any output. That means, both the diode will remove both the halves and there will be no output obtained at the load side. So, the dual clippers are basically used with the biasing circuits or with for the biasing conditions. So, the picture shows the biasing connected with the diode. So, the biasing is such that the positive side of voltage VR1 is connected with the N side of diode D1 and the negative side of voltage VR2 or the battery VR2 battery having the voltage VR2 is connected with the P side of diode D2. So, with this circuit we are getting certain amount of output on both the side. So, the waveform can be modified in both the cycles or both the half using the dual clippers. Now, let us discuss the working of dual clippers or the combination clippers in more detail. So, the circuit operates using a simple principle. If both diodes are reverse biased or if they do not conduct, the input signal would appear across the diode and also appears at the output. Now, if one of the diode starts conduction, their respective battery voltage will start to appear at the output. During the positive half cycle, the diode D1 is forward biased while the D2 is reverse biased for input signal. But the diode D1 and D2 is reverse biased for the battery voltage VR1 and VR2 respectively. During the positive half cycle, the diode D1 is forward biased for input voltage and reverse biased for battery voltage VR1. So, when the positive half cycle of the input comes, the diode D1 gets forward biased due to the input voltage, but until the voltage is increased up to VR1, it will be reverse biased from the battery side. So, while the diode D2 is reverse biased for both the input voltage as well as the battery voltage VR2. So, at first the input voltage is less than the battery voltage VR1, thus the diode D1 is in reverse bias, while the diode D2 is already in reverse bias condition. Therefore, the input signal appears at the output when the input voltage exceeds the VR1, diode D1 starts conduction and battery voltage VR1 starts to appear at the output. So, in this way, until the voltage at the diode D1 exceeds the value of VR1, no output will be obtained at the load side. since the diode D1 will be reverse biased due to voltage VR1 and the diode D2 is completely reverse biased due to supply also and due to the voltage VR2. So, as soon as the voltage at the diode D1 exceeds the value of VR1, then the output will be obtained in the load side. During the negative half cycle, the diode D1 is reverse biased due to both input voltage and battery voltage VR1. So, when the negative half of the cycle starts, D1 will the reverse bias condition due to both the input voltage and also the battery voltage. So, during the negative half of the supply, D1 will act as an open circuit. Now, in this the negative half, the diode D2 will work and it will give the output, but again here the condition arises for the forward bias condition. So, the diode D2 is forward biased due to input voltage, but reverse biased due to the battery voltage VR2. So, until and unless the voltage exceeds the battery voltage VR2, the diode D2 will remain in the reverse bias condition even if the supply makes it forward bias. So, as the voltage across the D2 exceeds the battery voltage VR2, it will start conduction. So, at first the input voltage is lower than the voltage VR2, thus the diode D2 is reverse bias and it does not conduct, and the diode D1 is already in reverse bias condition. Therefore, the input signal appears at the output. So, when the input voltage exceeds the voltage VR2, the diode starts conduction and the battery voltage VR2 appears at the output. So, in this way we have seen the working of dual or combination clippers, in which we can change or modify or clip the voltage in both the halves, which is not possible with the series or shunt clippers, in which we can only clip either of the halves, either positive or negative. So, in this way we have studied the three types of clippers, that is series, the shunt and dual or combination clippers. Thank you.